Good morning, students. I am Dr. M. Trinita, working as an assistant professor in PG and Research Department of Mathematics. Today, I am going to teach a topic in financial mathematics. Let's move on to the topic, the doubling rule. Now, we have a look on the doubling rule. If you put funds into an account that pays interest at rate R compounded annually, how many years does it take for your funds to double? So now we are going to calculate how many years your funds will take to double. Since your initial deposit of D will be worth D into n plus 1 to the power n after n years, we need to find the value of n such that n plus 1 the whole power n is equal to 2. Now, n plus 1 the whole power n is equal to 1 plus 1 n r by n the whole power n, which is approximately e to the power n r, where the approximation is fairly precise provided that n is not too small. Now we are equating the right hand sides. So e power nr is approximately equal to 2. If we take log on both sides, nr is equal to 2 log 2 or n is equal to log 2 by r, which is equal to 0.693 by r. Thus, it will take n years for your funds to be double when n is approximately 0.7 by r. That is, for instance, if the interest rate is 1%, that is R is equal to 0.01, then it will take approximately 70 years for your funds to double. If we take R is equal to 0.02, it will take about 35 years. And if your R is equal to 0.03, it will take about 23 1 by 3 years. If R is equal to 0.05, it will take about 14 years. And if your R is equal to 0.1, it will take about 7 years. As a check on the preceding approximations, if you calculate the accuracy to 3 decimal places, 1.01 after the year of 70 years, the amount will be 2.007. If we are giving the rate of interest at 2%, 1.025 after 35 years, it will be returned as 2 rupees. And 1.03 after the year 23.33 years, it will be funded as 1.993. And 1.05 to the power 14 years is equal to 1.98, and 1.10 to the power 7 years is equal to 1.949. Suppose now that we borrow the principal P for 1 year at a nominal interest rate of R per year compounded continuously. How much is owed at the end of the year? Now we will calculate this. Of course, to answer this, we must first decide on appropriate definition of continuous compounding. To do so, note that if the loan is compounded at n equal intervals in the year, then the amount owed at the end of the year is P into 1 plus R by n the whole power n. As it is reasonable to suppose that continuous compounding refers to the limit of this process as n grows larger and larger, and the amount owed at time is calculated by using the formula limit p n tends to infinity 1 plus r by n the whole power n into p, which is equal to p into e to the power r. Next, we will move on to an example. If a bank offers interest at a nominal rate of 5% compounded continuously, what is the effective interest rate per year? To calculate the effective interest rate, we have a formula R effective. Effective rate of interest is equal to P e to the power R minus P by P. Here the nominal rate is 5%. So P e to the power 0.5 minus P by pi. If you take from the numerator P commonly and if we cancel, we get e to the power 0.05 minus 1, which is approximately 0.05127. So the effective interest rate is 5.125% per year. If the amount is P is borrowed for T years at a nominal interest rate of R per year compounded continuously, then the amount owed at time T is P e to the power RT. So this follows because if your interest is compounded n times during the year, then there would have been nt compoundings by time t, giving a debt level of P 1 plus R by n to the power nt. Consequently, under continuous compounding, the debt time t would be P limit n tends to infinity 1 plus R by n nt. Just we are combining P into limit n tends to infinity 1 plus R by n the whole power t. But already we have defined limit n tends to infinity 1 plus R by n the whole power n as e power R. So which is equal to P into e to the power RT. It follows from the preceding that continuous compound interest at rate R per unit time can be interpreted as being continuous compounding of a nominal interest rate of RT per unit of time T. So thank you, students.